Hi everyone, I'm Swati and welcome back to my series on mechanics. We are doing vectors right now. Yesterday video is all about unit vectors, resolution of vector, components of vector, and today we are going to do numericals on that. I bring up with my new videos from Monday to Thursday, so you can stay tuned with me to learn vectors. And today's video is all about numericals, so let's begin with that. Okay, so in the last video, we stopped at this point where I was telling you about XYZ plane. If a part of object is in XYZ plane, then it can be written as AXI cap, AYJ cap, and AZ K cap. And its magnitude can be calculated by squaring its component and taking under root. Now, if you want to calculate that direction, see, there is a difference. In 2D, only x and y plane, you have to divide ay by ax. You will get the direction. But in 3D, it is something else. In this, the vector, a vector, makes an angle of alpha with x-axis, beta with y-axis, and gamma with the z-axis. And we can use the cosine thing. Cos alpha, the angle with x-axis, can be determined as its x component divided by this a. It is like something this is base and this is hypotenuse. Similarly, for y component, it is cos beta, which is ay by a, the magnitude thing, and cos gamma is az by a. It is base by hypotenuse. Okay, so all you have to remember for 2D, it's simply a vector can be written as, or r vector. A is just a notation, but in mechanics we generally use r vector and we write in terms of x, y, and z. Okay, so let's take r vector and it can be written as xi cap plus yj cap. X and y can take any values, and for its magnitude you have to square it, x square plus y square, and to get the direction, it's simply tan theta, which is y by x. Okay, and theta is the angle between this resultant vector and the horizontal base. And for 3D, your r vector, position vector, can be written as xi cap plus yj cap plus zk cap. Okay, and its magnitude can be calculated by squaring all the three variables, that is x square plus y square plus z square, and then your cos alpha can be written as x component by this magnitude. Okay, there is a tip. If you are a math student, then this thing will help you in your 12th grade when you read vectors. Okay, but yeah, it's very important. It's a tool. See, it's a mathematical tool which you require to do physics. So if you master this, then it would be easier for you to deal the maths. Physics itself is not that hard, but yeah, the maths part makes it a little bit trickier. But I don't think that the physics is that hard. I don't think so. Okay, so now, let's do some questions. Suppose in a Cartesian plane, we are given two vectors. One is this, A vector, and another is this, B vector. And you have to find the components of A vector, B vector, and the resultant. They can also ask, tell me the x-axis and y components are positive or negative. So you have to simply resolve it. You can see, okay, let's do from the diagram. A vector is here. Okay, so if you resolve it, ax would be here AY. Okay, that means Ax is in negative x direction and AY in positive y direction. So A vector can be written as Ax minus I cap plus AY plus J cap. Okay, that means its x component is negative and y component is positive. Now for B vector, B is here. If you want to resolve it, By will be here and Bx there. So Bx is positive and By is negative. So for B vector, it is Bx plus I cap plus By minus J cap. Now for the resultant, we can use here the triangular law, and then we can say where a resultant is, and then we can resolve it. Okay. So if this is my A vector, this is my B vector, then resultant should be here in the opposite direction. R should be here. So for that, Rx would be here and Ry there. Okay. So your resultant vector would be Rx plus I cap plus Ry J cap. Okay. That's easy. Now let's do something. Let's say you have a vector which is 3I cap plus 4J cap. You have to calculate its magnitude and direction. So for the magnitude, all you have to do is simply you can square it 3 square plus 4 square, that is 9 plus 16, that is 25. It is simply 5. And for the direction, what you can do, you can use theta tan inverse simply y component by x component, that is 4 by 3. As simple as that. Okay. Then if they are in some other direction, let's say minus 2y cap and minus 2 root 3 j cap, something like this, or let's take it plus. If they are in which coordinate they are, then it's in second quadrant, so angle should be like this. And you should remember that this 4 by 3 is actually 53 degree. Yeah, you must remember that. Tan 53 degree is 4 by 3. Sine 53 degree is 4 by 5. They are standard and they often come in competitive. And cos 53 degree is 3 by 5. Remember that. And you can have 37 also. So sine 37 degree, which is its complement, will become 3 by 5. And cos 37 degree will become 4 by 5, just the opposite. And tan 37 degree would be 3 by 4. Okay. Okay. So you've been asked, consider a vector which is 4i cap plus 3j cap and a b vector which is 7i cap plus 24j cap. Okay. Now you have to find a new vector whose magnitude is same as b and is parallel to a. Find a vector with magnitude b and parallel to a. Now if it is parallel to a, then that means that is in the same direction of a. So what you have to do, you have to find the unit vector of this a and the magnitude of b. So for the magnitude, you can simply square the terms 49 and 24. 24 is 256. Let's do it. No, sorry. 576. Sorry. It's 576 and that gives you a 625, which is 25. So the magnitude is 25. Now, if it is parallel to A, though, you have to get the direction of A. That means you have to calculate its unit vector. And you can calculate its unit vector by dividing the vector to its magnitude. So the vector is 4i cap plus 3j cap. And for the magnitude is simply 4 square plus 3 square. Then it is 4i cap plus 3j cap over 25 and 5. So it's simply 5. So the C vector, new vector, is simply the magnitude of B vector into direction of A. If it is in parallel, that means it's in the same direction. So it's 25 times 4i cap plus 3j cap over 5. And you can simply cut it. It becomes 20i cap plus 15j cap. Okay. Similarly, you can have another question like this. Suppose there is an object which is moving in a direction of an object moving in a direction of minus 4i cap plus 3j cap with a speed of 20 meter per second. Find velocity vector. Now for the velocity vector, you should have magnitude plus direction. So they have given you the speed, the magnitude, and the direction. But this direction could have some magnitude, so you have to get its unit vector. So you can only have the direction with a magnitude of 1, and you can multiply with the magnitude of 20, and then you can get its velocity vector. Simply. So let's say for the direction, V cap is simply minus 4i cap plus 3j cap over 16 plus 9, 25, that is 5, simply. And then the velocity vector will become 20 times of this direction. 20 times of this V cap, that is 20 times of minus 4i cap plus 3j cap over 5. And you can simply 5 4s are that it gives you minus 16i cap plus 12j cap. Okay, so it's that simple. Now let's do the last question of this video, and tomorrow and we will meet on Monday, and then we'll do some vector algebra. Okay, so the last question is, suppose your object, there is one object, an object is moving along northeast direction and northwest direction, southwest direction, southeast direction with a speed of 10. With a speed of 10 meter per second. And you have to find velocity vector. Find velocity vector. Okay. So by this, they meant to ask you that first, if the object is moving in this northwest direction, for example, exactly, that it makes an angle of 45 degrees here. So if you resolve it with a unit vector as a magnitude of 1 here, then it gives you, let's say its unit vector r cap gives you 1 cos theta I cap plus 1 sin theta j cap. That is the resolution. And theta is 45 degree. So cos 45 is 1 by root 2. Then it is 1 by root 2 I cap plus 1 by root 2 j cap. There is some problem. Okay. So it's like that if it is moving in north east direction, then its velocity vector becomes what? 10 times of this direction, which is simply 1 by root 2 I cap plus 1 by root 2 J cap. Okay. Now, if it is moving in what? Northwest direction, somewhere here, then you can simply say that in northwest direction, the velocity vector will do like this, without going to the actual method. Just do it like quickly. Let's do it quickly. So if it is 45 degree, then x is negative and y is positive. You can simply write as minus 1 by root 2 I cap plus 1 by root 2 j cap. There is a lot of problem. Okay, now if it is like southwest direction, then both are negative. So for the southwest, it's easy. You can do it without doing the whole method if you learn and understand the concept. Minus 1 by root 2 I cap minus 1 by root 2 j cap. Okay. And then again in south east direction, x is positive, y is negative. So for the southeast, velocity vector would become magnitude times the unit vector. I only take the direction and put the magnitude to be 1. So it is plus 1 by root 2 I cap minus 1 by root 2 j cap. Okay. So this is the last question of the video and it's not that hard. So this is all for today's video, and now we'll meet on Monday with some concepts, and now we'll just pick some more acceleration and we'll do some tricky things now. Okay, so thank you for watching this video and do like, share and subscribe for more such videos.